All right, so let's look at today's journal entry. We have a rational function, f of x equals 2x squared over x plus 2. And the first thing that I'm asking you guys to find are horizontal asymptotes and vertical asymptotes. Now, this was all before the world of derivatives. How do we find vertical asymptotes? Well, if I want to find a vertical asymptote, we're going to set the denominator equal to 0, and we solve it, and we have a vertical asymptote at x equals -2. If I want to find a horizontal asymptote, we're going to look at end behavior. We're going to look at the limit as x approaches infinity of 2x squared over x plus 2. And if you happen to remember the shortcut, we see that this is a rational function, polynomial on the top, polynomial on the bottom. We have degree 2 in the numerator, degree 1 in the denominator. Which one's bigger? Clearly the numerator is larger. In a case like this means that the limit is infinity. So our conclusion is that there is no, repeat, no horizontal asymptote. Excellent. That's part 1. Okay, part 2, the question asks to identify critical points. Well, if I want critical points, I know critical points means that the derivative is equal to 0 or that the derivative is undefined. We need to look at both of those, but that means we're going to have to look at the derivative. Let me zoom out appropriately here. If I'm going to take a derivative, okay, f prime of x, I have 2x squared over x plus 2. That's going to be a quotient rule problem. So, low-de high, high-de low, low, low. Everybody with me, please. Low-de high, high-de low, low, low. So, x plus 2 times 4x minus 2x squared times 1 over x plus 2 squared. That's the derivative. It's going to be supremely helpful. Your life will be made better if you take the time to clean this up. And this should not be a difficult one for us to clean up. So x plus 2 times 4x. I can distribute the 4x through the parentheses that way. 4x times x, 4x squared. 2 times 4x is 8x minus 2x squared over x plus 2 squared. Still have more cleaning up to do. 4x squared minus 2x squared is 2x squared plus 8x over x plus 2 squared. You can stop there. That's great. I would say that's simplified more than enough. And now here's where we need to think about this as a fraction. This is just a simple, well, not a simple, it's an interesting fraction. What I know is if the numerator of a fraction is equal to 0, then the whole fraction is equal to 0. I also know that when the denominator of a fraction is equal to 0, the whole fraction is undefined. So, if I'm asking where is f prime of x equal to 0, what that implies is all I need to do is figure out where is 2x squared plus 8x equal to 0. I can solve that pretty quickly by factoring out the 2x. 2x times x plus 4 equals 0. So 2x equals 0 or x plus 4 equals 0. We get 0 and -4. Great. Alright, well, that's not it for critical points. I also need to look where is f prime of x undefined. Where's my derivative undefined? What we already said is that if I have a fraction and the fraction's undefined, that means that the denominator is equal to 0. Well, if x plus 2 squared is equal to 0, that means that x plus 2 is equal to 0. So x equals -2. finally, if I'm going to classify my critical points as relative max, relative min, or none of the above, what I'm going to have to do is let's do our number line test. And again, this is the number line test for f prime. It's a little bit different. We're going to have -4, -2, and 0, all three of those on our number line. At 0, the derivative is 0. At -4, the derivative is 0. And at -2, my derivative is undefined. What that means is I have these 3 points are going to divide the interval into 4 partitions, or subdivide the number line into 4 partitions. 1, 2, 3, 4. Same game as always. For each point, select a test point. So to the left of -4, I'm going to go with -5. Between -4 and -2, how about -3? I'll use -1. And I'll use +1. Now, where do I plug those points into? I plug them into the derivative. And we have that f prime of x equals 2x squared plus 8x over x plus 2 squared. I can, if I want to, and I'm going to, I'm going to factor the numerator. I can take out a 2x, leaving the x plus 4 over x plus 2 squared. And what we're going to do is let's evaluate this function, that derivative, at the test points. If x equals -5, plug it in. 2 times -5, I get a negative. -5 plus 4, another negative. -5 plus 2 is negative, but I'm squaring that. Negative times negative is positive. Denominator, negative squared is positive. Positive divided by positive is positive. So on this interval, what I expect is my derivative will always be positive. Now let's go between -4 and -2. X equals -3. Plug that in. Same game as before. 2 times -3 is a negative number. -3 plus 4 is positive. -3 plus 2 is negative, and now we square it. Negative times positive is negative. Over negative squared is positive. Negative over positive is negative. The derivative will be negative from -4 to -2. Let's do it with -1. 2 times -1 is negative. -1 plus 4 is positive. -1 plus 2 is positive, and we square that. Negative times positive is negative, over positive squared, negative. Okay? The sign didn't change. Sometimes that happens. Okay, x equals 1. Plug that in. 2 times 1, positive. 1 plus 4, positive. 1 plus 2, positive, and now we square it. Positive times positive is positive. Divided by positive squared, we get positive. Woo! Love it! God, I love being a calculus teacher. So, we've got all of this wonderful stuff. I could say that f of x is increasing. Well, where is the function increasing? We're increasing on the interval -infinity to -4, including at -4. We could also say we're increasing from 0 to infinity. We could say that f of x is decreasing. Well, where is it decreasing? And this is where I want to be careful. We're going to say it's decreasing from -4 to -2, but I cannot include -2 because the function's not defined at -2. And then we continue from -2 to 0. If I wanted to classify my critical points, let's see, I have a relative max at x equals -4. Why do I have a relative max at x equals -4? Relative max at x equals -4 because f prime changes from positive to negative, I could say I have a relative min at x equals 0 because f prime of x changes from negative to positive. Now what happens at x equals negative 2? Well, the derivative's undefined. Now James, before you jump in and say cusp point, I know that's your favorite word. This actually is not a cusp point. The reason that the derivative is undefined, the actual original function was undefined at negative 2. We don't have a cusp point at negative 2. We have a vertical asymptote at negative 2. So to summarize, we have a relative max at negative 4. We have a relative min at x equals 0. And we have a vertical asymptote at x equals negative 2. In the units coming up, we're going to take all of this information, plus we're going to look at the second derivative to do some curve sketching. So we're going to come up with the graph of the original function using all this information. For now, what I wanted you guys to get out of this is practice with identifying critical points. So we looked at the first derivative, where is it equal to 0, where is it undefined. Some more practice with our number line test. Practice with justifying relative max and mins, as well as intervals of increasing and decreasing. So if you're feeling good about all that, feel free to high five your neighbor. That concludes this journal entry. We really are putting some beautiful work into your journals, and I will be checking these next week when I come back. So Giovanni, if you haven't been taking notes, you might want to get some help from Mario now. Anyway, I'll talk to you guys later. I'll see you on Monday, and I will probably bring back some goodies. So be good for all of the teachers who are covering for me while I'm in Massachusetts. Bye!